So speed is the rate at which distance of an object travels per unit of time. It is a scalar quantity. You do not attach a direction to it. It will only be a number and then a set of units, typically a unit that demonstrates distance over time. Per usually means divided. So distance divided by time, which will be meters per second, miles per hour. And you can see in the first example here that you encounter speed every day when your parents drive you to school or whoever drives you to school. So in a car, if you're going 60 miles per hour constantly, you will travel 60 miles in an hour. So 60 miles per hour is a speed that you're going. 60 miles is a distance, and an hour is the unit of time we're using. If we go down here, here's another example using the metric system, because we don't use miles. Remember, that's customary. We use metric. So an object with a speed of 5 meters per second can travel 5 meters in 1 second. So 5 meters per second is our speed. 5 meters is our distance, and 1 second is our time. So if we look at 5 meters over a unit of time, gives us a speed of 5 meters per second. So then I'm going to give you the equation for calculating speed. We have speed equals, and then this triangle is a delta, and a delta is a sciencey way of meaning change in. So when you see that triangle, that delta, speed equals change in distance over change in time. And I have the units meters and the units seconds because that's what we're most typically going to deal with in this class, although, and you'll see later, it does change. Sometimes it could be kilometers over hours, or sometimes it could be decameters over seconds. It just depends on the problem. But for now, let's stick with meters per second because that's going to be the majority of problems we do. And for those of you who aren't too keen on algebra, there's this triangle here, which can help you with figuring out and manipulating the equation. So if you look at this first triangle, speed equals distance over time. I'm going to draw in my deltas. Change in distance over change in time. And if you look at this triangle, we're solving for speed, and that equals distance divided by time. So now, typically what you would have to do in algebra is a one-step equation. Let's say you wanted to solve for distance. Typically you would have to multiply both sides of the equation by time. The time would cancel out, and then you would get change in distance equals time times speed. For those of you who that isn't so easy for you, this is where the triangle, the equation triangle, can come into play with helping you. If you look here, this time D is highlighted. So that tells you distance equals speed times time. And as you can see, that's our equation here. And if you look down at the bottom, what's highlighted is T, meaning that you're solving for time if you need to. And time equals distance divided by speed. It's just a way to do it without having to take the time to actually manipulate the question. For some of you, memorizing this triangle might be easier. Here, I want you to write this down, is the format of how we're going to be doing these problems. It's called the guess strategy. And each letter, guess, stands for a certain thing. Here we have G. G stands for what's given to you in the problem. Just to let you know, this is what the format you're going to use when you're encountering story problems in physics. And we're going to see the guess strategy pop up a lot of times The speed formula is not the only formula we're going to use. So G is the givens. That's what's given to you in the story problem, the variables of the equation that are given to you. U is unknowns, and that simply just means, what are you trying to solve for? E is the equation. That's where our triangle comes into play. D is always on top in the triangle. S is substitute. I like to call it the plug and chug. You just plug in your givens into the equation and then you solve, which is our next S. So I'm going to give you a problem just to kind of give you a kind of an idea of how GUSS works and some of these problems you're going to be encountering. So here we have a passenger train travels from Boston to New York, a distance of 350 kilometers in 3.5 hours. What is the train speed? Now you notice we're not using meters per second here, we're using kilometers and hours. So let's start with our G of our guess, our givens. What do we know? Let's read this problem and figure out what information they gave us out of speed, distance, and time. They gave you a distance. It's 350 kilometers. They gave you a time, which is 3.5 hours. So what are we trying to figure out? Oftentimes, you're going to look for what you're trying to figure out in the last sentence of the problem. Now, this isn't going to happen every time, but most of the time, you're going to see it in the last sentence. Here, the last sentence is, what is the train speed? So what we're solving for, what it's asking for, is speed. That is our unknown. So now we have to look at the equation for speed. Speed equals change in distance over change in time. And here we get to substitute, plug and chug. We're going to plug the 350 in for change in distance. And we're going to plug the 3.5 hours in for change in time. And then we're going to chug it out. Find out what the answer is. So, speed equals 350 kilometers divided by 3.5 hours. And when you solve that out, speed equals 100. And then the units we're going to use are revealed in your equation. We have kilometers over hours. So our unit will be 100 kilometers per hour. So let's do one more together. I want you to write both of these down. And this next one we're doing is a two-part problem, so I'm going to divide guess in half. So, a runner completes a 400-meter race in 43.9 seconds. In a 100-meter race, he finishes in 10.4 seconds. In which race was his speed faster? So let's take the first part of this. A runner completes a 400-meter race in 43.9 seconds. What do we know? We know distance equals 400 meters. We know time is 43.9 seconds. And if you look in the last sentence, in which race was his speed faster? So we're solving for speed. Speed equals change in distance over change in time. If we substitute it in, put 400 in for distance, 43.9 in for time, plug and chug it out, we get speed equals 400 meters divided by 43.9 seconds. Solve it out, we get meters over second. 400 divided by 43.9 is 9.1. Sorry, I got the microphone. Meters per second. Now let's do the second part of this problem. In a 100-meter race, he finishes in 10.4 seconds. What do we know? Distance is 100 meters. time is 10.4 seconds. We're solving for speed. Speed equals change in distance over change in time. Substitute it in, plug and chug. 100 meters goes in for change in distance, 10.4 seconds goes in for change in time. Solve. So speed equals 100 meters divided by 10.4 seconds. And when you calculate it out, 100 divided by 10.4 equals 9.6. And again, we have meters over seconds, so our units will be meters per second. So let's go to the last part of this question. In which race was his speed faster? His speed is a higher number in the 100-meter race. So speed was faster in the 100-meter race. And like I said, or maybe I didn't say, I can't remember, you will not be using guess once you get the hang of this. But for right now, I'm going to require it. Once you get the okay from me, you don't have to use it anymore. And some of you will want to use it every time because it helps you logically think out each step. But for now and tomorrow when we do these in class, I want you to be familiar with and be using the guess strategy. So, I'll see you tomorrow. Have a good time doing your other homework. Bye.